Parallel lines, of course you've seen parallel lines before, you're pretty familiar with them. Parallel lines, by definition, they never intersect because they're going in the same direction forever and ever. They're coplanar, meaning they are on the same plane. They go in the same direction and have the same slope. And then there's also a symbol for parallel lines, so like these little arrows. If two lines have the matching number of little arrows like that, that means that those lines are parallel. Okay, and then this might be new, skew lines. Skew lines are not coplanar, they don't intersect, but they aren't parallel. So what do they look like? I'm going to give you kind of a visual. So like parallel lines never intersect because they go in the same direction. Like if one of those lines was slanted even a little bit, eventually it would run into the other line. So parallel lines never intersect because they're going in the same direction. Skew lines never intersect, but they never intersect because they're on completely different planes. So for example, one line's going this way and then one line's down here going this way. They're not parallel, but they never intersect because they're on different planes. So that's what skew lines are for. I can't draw it on paper because paper is like it's a plane, but envision like a highway overpass with like one road going underneath and then another road going on top. They never intersect. Those are skew lines. So now we're going to look at an example of parallel lines and skew lines on a picture. So for example, parallel lines in this picture, if you were to identify a set of parallel lines, would be like line AB and line DC. Those are parallel. So we can say that line AB is parallel to line DC. And this symbol right here means parallel. Okay, and then another set, just to give you another example, might be, there's a lot of parallel lines here, so maybe CH right here is parallel to BG. So line CH is parallel to line BG. And there's more, but the picture would get very crowded. Okay, and then skew lines, those are lines that are not parallel, but they never intersect. They're on different planes. So for example, maybe line AD right here, and then BG. They're just totally different areas, not parallel, but they're not going to intersect, so they're just skew. So line AD and line BG are skew lines. Okay, and then the next thing is parallel planes. Parallel, I just said it. Parallel planes. Parallel planes are exactly what they sound like. It's planes that run parallel and never intersect. So for example, it's kind of like these two clipboards, like parallel planes, just like they're parallel to each other, they never intersect. They might be flat like this. They could also be slanted as long as they have the same slant or the same slope. They could go on and on forever and ever and never intersect. So we'll identify parallel planes in this picture. So for example, like this plane right here, top rectangle is parallel to this plane down here. They're parallel. So we can say plane. And when we name a plane, we name it only by 3 points, even though there's like 4 on this rectangle. When we name a plane, we're naming that whole like flat surface that extends beyond this rectangle even. We can say plane ABC is parallel to plane FGH. And then also, if we were to do skew planes, there would be no such thing. Skew planes do not exist. So, like, if you think about skew, like, it would mean it's like slanted, but they would always run into each other. So, skew planes don't exist. But something that does exist that comes up in the questions is perpendicular planes. Perpendicular planes, or planes that are perpendicular to each other. So that would be planes that intersect at a 90-degree angle. So I'm going to use this picture over here and say, okay, plane BCG is perpendicular to plane ABC. Plane BCG, oh, I guess I can do bleep. BGC goes fine. Okay, BGC is perpendicular to plane ABC because they form a 90-degree angle when they intersect. Okay, and then for these questions here, it says, think of each segment in the diagram of chart of a line. Which line or plane appear to fit the description? So here's our picture, and then we're just using this vocabulary here to answer these questions. And I'm going to be using pencil because as I go, I'm going to like label the shape and then erase for the next problem so it doesn't get too crowded. It says lines parallel to line AB. So here is line AB right here. Lines parallel to that would be line DC, line GH, and line EF. So I'm going to write that down. So parallel to AB would be line DC, HG, and EF. Like I said, after I'm done, I'm going to erase my marks so that way I have a clear canvas for the next problem. Okay, the next one says lines perpendicular to BF. So BF is right here. Lines perpendicular would form a 90-degree angle. So like BC, FG, AB, and EF would all be perpendicular to that line. So I could say line AB, BC, so let's say FG, and EF. Line AB, BC, FG, EF are all perpendicular to form 90-degree angles with that line. Okay, next one. Line skew to CD and containing point E. So first identify CD, okay. Skew to CD containing point E. So skew means that they're not parallel, they never intersect, so EH would be skew. And then also EA would be skew to that line as well. Then number 4, plane perpendicular to ABE. ABE is the front plane, is the front rectangle. So planes perpendicular to that would be the top plane intersect at 90 degrees, this plane on the side, this plane on the side, and the bottom. So there's actually 4 planes that are perpendicular to that front rectangle. So plane ADH, the side, the top DCB, the side BCG, and the bottom each HG. Okay, and then the last one, a plane parallel to plane ABC. So ABC is the top plane, just ABC, got it. The plane parallel to that would be the bottom plane, plane EHG. Okay, and then we'll move over to the other side over here. Again, just continuing with vocabulary. Okay, over here. Over here, we're going to talk about angle pairs formed by a transversal. So we'll have parallel lines, and then what a transversal is, it's a line that intersects both of those lines. So this here, the blue line, is a transversal. So you'll notice in some of these examples, the two lines aren't necessarily parallel, as you can see, but the concept and the vocabulary stays the same. And what we're working toward is toward parallel lines. So like on Monday, you'll see just parallel lines, but here they're talking about the vocabulary, and they don't always have it with parallel lines. But if you could like pretend or envision, it'll make everything kind of come together. So a transversal right here is a line that intersects two coplanar lines at two different points. So the transversal right here. Transversal. Okay, and then the transversal creates angle pairs or angle relationships. The first one is, tell me if you remember this from, actually just tell me if you recognize any of these words. Alternate interior corresponding angles. Do you recognize any of that? Kind of, maybe. It's supposed to come up in 8th grade. Okay, so first things first, corresponding angles. Okay, so corresponding angles, they look like this. So in this little box, we're going to draw actually 4 sets of parallel lines. 1, 2, 3, 4. I drew 4 sets of parallel lines, and each set of parallel lines is going to have a transversal. Okay, so corresponding angles are angles on the same side of the transversal and either like just above the parallel line. So these two lines are corresponding. And what we're getting towards is like corresponding angles have the same angle measure. So that's where we're headed with this. So corresponding angles have the same angle measure. These two angles are corresponding. Also angles that are corresponding this angle and this angle. So same side of the transversal, and this time they're both underneath the parallel lines. And then this angle corresponds with this one. And this angle corresponds with this one. Okay, the next type of angle pair that we're going to learn is alternate interior angles. Alternate, that word means like alternate sides. And then interior is on the inside. So we're going to draw just 2 examples for this one. So two sets of parallel lines with transversals. So alternate interior. So alternate sides of the transversal on the interior of the parallel line. So alternate interior would be this angle and this angle, or this angle and this angle. Alternate sides of the transversal on the interior of the parallel lines. And these angle pairs have equal values. So if you know one of the angles and you know that these lines are parallel, you know the other angle is equal to it. The next word is alternate exterior. Oh wait, in the wrong spot. Alternate exterior angles. We have parallel lines, the transversal, parallel lines with the transversal. Alternate meaning alternate sides of the transversal, exterior of the parallel lines. So like this angle with this angle are alternate exterior, or this angle with this angle, alternate exterior. And then alternate exterior angles will also be equal in value. And then the last one is called consecutive interior angles. Depending on the resource or the textbook, sometimes they're called same side interior angles. So we're going to draw an example here. And then, so consecutive or same side interior, they're on the inside of the parallel lines and just consecutive right next to each other. So these two are consecutive interior and these two. Notice how I used a different symbol. I didn't use the arc because the arc generally means that angles have the same measure. But these angles aren't the same measure. One's like acute and one's obtuse. So they're not equal, but they do add to 180. So they're supplementary angles. And the math part will come up tomorrow. Or not tomorrow, Monday. Okay, then. Okay, down here we're going to practice just identifying angle pairs. They made it sideways, which is kind of annoying. So like kind of envision it like this, and you have like consecutive interior angles here, or alternate exterior would be 4 or 6. Corresponding would be like 1 and 5, and so on. It says to classify each angle pair as corresponding alternate interior, alternate exterior, consecutive interior, vertical angles, or linear pair. So we're going to look at each one. I'm going to use a pencil so I can erase 1 and 7. So 1 and 7 here, those are alternate sides of the transversal on the exterior. So they are alternate exterior. Alternate exterior angles. Then B, 8 and 3, 8 and 3 right here. They are same side on the interior of the parallel lines, so they are consecutive interior angles. And I know same side interior would be easier to remember and say, but your specific textbook, the McGraw-Hill one, uses consecutive interior. And then 6 and 5. Okay, 6 and 5 right here. Notice how they are adjacent and they form a straight line together. So they are a linear pair. Four and 2. They're opposite each other. Those are vertical angles. Vertical angles. And this is exactly what we're going to be practicing with the activity on Tuesday, just so you know. And then 8 and 2. Here's 8 and here's 2. Alternate sides of the transversal on the interior of the parallel line, so that would be alternate interior angles. And then F, 7 and 3. Let's see, 7's right here, 3's right here. They are corresponding angles. One more thing that shows up on the homework, just so you're aware. Sometimes they'll show like parallel lines and they'll show like a transversal here and a transversal over here. And they'll ask, okay, what's the relationship between, let's say, 1 and 3? But there's like numbers everywhere, like this, and they say, okay, what's the relationship between 1 and 3? So what I would do in this scenario where there's a lot going on is you cover up everything that doesn't have 1 and 3, and then you just look at this part, and then you can see that, okay, 1 and 3 are alternate exterior, and then here is the transversal right here. So just cover up whatever part they're not talking about, and you'll see the picture just like we saw it in the notes. So I'm going to